Okay, so we're going to start part 2 of finding area between two curves. Again, the most important part is making sure you draw an accurate diagram. So let's start with number 1. We have y equals negative x squared plus 2x plus 3 and y equals 3. So I know what y equals 3 looks like. I'm going to start with that one here. Okay, so I'm going to now use my calculator to graph the other line so I can see what that looks like. That would be, let me clear out my old graphs here. So that's negative x squared plus 2x plus 3. And we have a upside down parabola. So I'm also going to check and see where the two lines cross. So I'm also going to type in my y equals 3 so I can see where they intersect. Now, if it looks like they're going to intersect at nice, easy points, you can always go to your table of values and see if you can find a matching point there. So I see they cross at 0 and again at 2. So I'm going to draw a quick sketch of my graph here. Doesn't have to be beautiful. And I'm going to shade the region between the two curves. Okay, so we talked in part 1 about how when we find the area, we're going to do the integral from a to b. So my starting points would be 0 and 2 of top minus bottom. So the graph on top of the shaded region is the green graph here. So my parabola, negative x squared plus 2x plus 3 minus the graph on the bottom, which is 3 dx. So now I'm going to take the integral. Now before that, I'm going to simplify it a little bit. This is negative x squared plus 2x dx. So I'm going to add and divide. That's negative 1/3 x cubed plus x squared. And I'm going to evaluate from 0 to 2. So now I'm going to do top minus bottom again. I'm going to plug in the top number, which is 2. Minus, I'm going to plug in 0. But if I look at this, if I plug in 0, I get 0 back. So I've got 2 to the 3rd power, which is 8, so negative 8/3 plus 4 minus 0 gives me 4/3. And again, if we want to check our work, we're going to go to our main screen and we're going to do math down to number 9. And we're going to type it in exactly how we see it. So that's negative x squared plus 2x dx. And I should get 4/3. Okay, so let's take a look at a second type of question. So another graph that we can have sometimes is trig graphs. Now, trig graphs, like sine and cosine, repeat forever. So I didn't graph this for you because normally I would graph it first and then make copies for you guys. But since we can't do that, we're going to have to sketch it ourselves. So the sketch we're going to be looking at is let's draw one period of the sine curve. Try your best. I know it's tricky sometimes to draw those curves. And then let's draw one period of the cosine curve. So I'll do a quick labeling here. So we have the sine and we have cosine. And we're going to find the area of the region between those two curves. And I'm just going to do the area that we can see there of that first region right here. So I'm going to shade that in. Okay, so we have to think about this. Now, 2 times on the unit circle where sine is equal to cosine, because I want to know where these two graphs cross. 1 time is at pi over 4, right? That's where they're both equal to root 2 over 2, root 2 over 2. So I'm going to mark that off here, pi over 4. The second time where they cross that would be 5 pi over 4. That's where they're both negative root 2 over 2. Okay, so let's set this graph up. We're going to take the integral from a to b, so pi over 4 to 5 pi over 4, of the top minus the bottom. Now my purple graph is on the top of the shaded region, so that's sine of x minus the orange graph is on the bottom, so cosine of x dx. So now I'm ready to take the integral. So I got to think backwards. So what derivative gives me sine? So the derivative of cosine is negative sine. So if I want positive sine, my answer is going to be negative cosine. And the derivative of sine is cosine, so negative sine would be negative cosine. Okay, so now we're ready to plug in. Top minus bottom. So I'm going to plug in 5 pi over 4 first. Minus, I'm going to plug in pi over 4. And we're going to solve. So cosine of pi over 4 and sine of pi over 4 are both negative pi over 2. So negative root 2 over 2. So that would be positive root 2 over 2 plus positive root 2 over 2 minus, okay, both of these are root 2 over 2. So that would make that negative root 2 over 2, negative root 2 over 2. Which now makes them all plus. So I have 4 root 2 over 2's, which simplifies to 2 root 2. And if you check that on your calculator, you'll get the decimal 2.828. So you might want to take some time just to practice plugging that in your calculator, and you should see if you get that decimal. Now you do want to make sure you're in radians. Okay, let's try one more. So let's go to number 3. Number 3, we have two functions, 3x cubed minus x squared minus 10x, and negative x squared plus 2x. Okay, so I'm going to get these graphed, and I am going to use my calculator to help me out so I can find all the points of intersection. So I'm going to go to my y equals, type these graphs in. So I've got 3x squared minus, oh, that's a cube, sorry. Got to fix that, that's a cube, minus x squared minus 10x. And I've got negative x squared plus 2x. There we go. Okay, so it looks like I've got 3 points where these graphs cross at. So I'm going to find the first one down here. I'm going to go to second, trace, intersect. I'm going to go between the blue and the red line, press enter, and they cross at -2, -8. So I'm going to mark that on my paper here so I know where to draw these graphs. They also cross at 0, 0. And then it looks like they cross at 2, 0. So if I want to check my table of values to double check that, yep, they cross at 2, 0. So now I can go ahead and draw a sketch. So I've got a parabola. And then I've got a cubic function. And this one I'm looking for the region that's bounded by both of those graphs. Now this ends up having two regions. I've got this region over here that's enclosed by those two graphs. So I'm going to shade that in. And then I've got this region right here. Okay, so that means two regions, I need two integrals. So I'm going to set up the first integral. So I'm going to do this first section right here. I'm going to go from, that one went from -2 to 0. And for this first region, the green graph is on the top. So that's the cubic function. 3x cubed minus x squared minus 10x minus the red graph's on the bottom, -x squared plus 2x. Okay, then I'm going to add the second shaded region. So that one goes from 0 to 2, and they switch places. Now the red graph's on top, so the -x squared plus 2x minus the green graph is on the bottom, 3x cubed minus x squared minus 10x dx. So I'm going to find this area and then add them up. So for this one, and some of these more complex equations and problems, I'm going to let you guys use your graphing calculator to solve for you. The most important part is making sure you write down the integral. That's where you would get most of your points on a quiz or a test. Okay, so I'm going to go to my main screen here, and I'm going to type in this first integral. So I'm going to go to Math, Integral, -2 to 0. I'm going to type this in, 3x to the third minus x squared minus 10x minus -x squared plus 2x. And that gives me 12. Nice and simple. Okay, so now I'm going to do the same thing with the second equation here. So I'm going to go back to Math, number 9, and I'm going to type this one in, 0 to 2. -x squared plus 2x minus 3x to the third minus x squared minus 10x. Just be careful with your parentheses on ones like these. Oh, I get 12 again. So even though they don't look like they're the same area, they actually are. So this 12, this is an area of 12. So when I add them up, that gives me a total area of 24. Okay, so that concludes part 2 of our area lesson. So make sure if you have any questions or if you are stuck on one of these to go back and rewatch. You can pause and rewatch as many times as you need to. Or you can let me know if you have any questions and we can make sure we go over some more examples.